Distinguish between independent and mutually exclusive events. So first, let's have definitions of what those mean. So independent events is one event that does not impact the result of a second event. So that would make those two events independent. Now, mutually exclusive events are two or more events that share no common outcomes. So if there's no overlap, there's nothing that is shared, then they are mutually exclusive. So what we know, we're going to do a little example here, or in a minute here. If two events are independent, we know that the probability of A given B is equal to the probability of A. We know the probability of B given A is the same as the probability of B. And we know that the probability of A and B can be found by multiplying the probability of A times the probability of B. Now, if they're dependent, right, because if they're not independent, they're dependent, we know that the probability of A given B and the probability of B given A do not equal the single probabilities of probability of A or probability of B. And when we're finding the probability with and, we don't just simply multiply the two probabilities. The probability of A and B is the probability of A times the probability of B given A. So we have more dependencies there with the and probability. So given the information below, can we determine if the pairs are independent or dependent? And we're going to do three problems here. So we know that the probability of A is 1/10, probability of B is 4/10, and the probability of C is 5/10. So if the probability of A given B is 2/10, what do we know about A and B? Well, if the probability of A given B equals the probability of A, then they're independent. But the probability of A given B does not equal the probability of A because 2/10 does not equal 1/10. So A and B are dependent. What about B and C? So if we know the probability of B given C is 0.4 or 4/10, what does that tell us? Well, if we're looking at probability of B given C, we're going to compare that to just the probability of B. And as you can see, the probability of B given C and the probability of B are both 4/10. So since they are equal, B and C are independent. And one more, let's look at A and C. So if the probability of A given C is 1/10, because A comes first and A given C, we're comparing to the probability of A, which is also 1/10. So because A given C and the probability of A are both 1/10, 1/10, they are, A and C are independent. Now, let's go to mutually exclusive events. If A and B are mutually exclusive, then the probability of A given B is 0, the probability of B given A is 0, and the probability of A and B is 0. Because, right, mutually exclusive means they share no common elements. So all of these items would be 0. So let's go to example 2. If the probability of A equals 0.72, the probability of B is 0.19, and the probability of A and B is 0.12, what do you know about A and B? Well, pretty easy here, because all we have to look at is the probability of A and B. And we notice it's not 0. So because the probability of A and Z is not equal to 0, we know these are not mutually exclusive. Because there is a value for the probability of A and B, that means they share common elements. So they are not mutually exclusive. Part 2, if the probability of C is 0.32, probability of D is 0.59, and the probability of C given D is 0, what can you say about C and D? Well, here we have probability of C given D is 0, and therefore we know they are mutually exclusive because they do not impact the other with no shared outcomes. Now, with that being said, two events cannot be both independent and mutually exclusive. Because if you are independent, then the probability of A and B is the probability of A 8 times the probability of B. And we know that mutually exclusive means that the probability of A and B is 0. So for the probability of A and B to be 0, it means one of them, either probability of A or the probability of B, to be 0, right? Because when you're multiplying two things together, the only way to have an answer of 0 is for one of them to be 0. And if an event has the probability of 0, then that means that the event cannot happen. So the event actually does not even really exist. And that is independent events and mutually exclusive events.